Good morning, welcome to my YouTube channel. So today I'm going to be talking about the quantum numbers that we have in chemistry. All right, so we have four quantum numbers. We have the principal, we have the azimuthal, we have the magnetic, we have the spin quantum number. Now the principal quantum number tells us the shell, right? It tells us how many shell does something have, or what is the value of n. You get me? And how do we get this value of n? Remember your electronic configuration where we have, for instance, sodium is 1s2, 2s2, 2p6, and 3s1. So these values, this 2, 3, 2, 1, these are the n value, and that's showing us the principal quantum number. And in case you don't understand how we come about this 1s2, 2s2, okay, so what you should know is that S can only take a maximum of 2 electrons, P can take a maximum of 6, F can take a maximum of 10. D can take a maximum of 10 and F can take a maximum of 14. You get that? So D can take 10. Are you getting? Now, how do we know how this thing proceeds like this? This 1s1, 2s2, and so on. Actually, there's a way we came about that. So we start with 1s, then 2s, 2p, then 3s, 3p, 3d, then 4s, 4p, 4d, 4f. You see that I'm increasing it. Then 5s, 5p, 5d, and 5f. This is where we'll stop. So you will now come down like this. You put arrow down, down, arrow down, arrow down. You see that those arrows are actually cutting across one and other. So now if you arrange it based on what you have here, you see that 1s is first, then 2s is next, then 2p, 3s, 2p, 3s. So you start from here. So that's 2p, 3s, 3p, 4s, then 3d, 4p. So let's stop there. So this is actually the progression of the energy of each orbital. So 1s has more energy, 2s has higher energy than 1s, and so on and so forth. So our principal quantum number is just that n value that we have at the back of each stuff like this. Are you getting me? So if I tell you that the valence electron of sodium, what will be the principal quantum number of it? It will be 3 because it is 3s1. So the answer is 3. Now azimuthal is, the symbol is L, and azimuthal is calculated as n minus 1, meaning that if your n value, for an instance, your n value is 3, the azimuthal will be what? L equals to 2. So for instance, if they say which of the following is not permissible, if they give you your n equal to 3, then you can have L equal to 2. You can also have L equal to 1. But you can't have L equal to 3. Are you getting me? Because your L value is n minus 1. It can be L minus 1. It can be, you can have 1, but you can't have 3. Because it has to, the maximum L you can have has to be n minus 1. If you don't understand that, please just try and go over the video again. Now for magnetic is NL, right? It starts from the negative L through 0 to positive L. So for instance, if your L is 2, in this case now, if your L is 2, then your magnetic will be minus 2, comma, minus 1, comma, 0, comma, plus 1, comma, plus 2. That will be the values for all your magnetic for this. So if you have for spin, your spin is ms actually, and it only has 2 values. That's the up spin and the down spin. So the values will be plus half or what, or minus half. So that's the summary of what we have about quantum numbers. So we can solve questions to get familiar with this concept. Make sure to like and subscribe and share.